Hello, and thank you for spending some time with me today. My name's Alan, and my wife and I together are also known as the Off-Grid Geeks. We're making this video today as part of a project where we compare 12-volt LED high-efficient lighting. We're also doing this video as part of the 2016 SW Video and Essay Contest, and we thank Survival Weekly for putting this contest on and giving us the opportunity to submit this. We hope that you leave this video today with some useful information on low voltage lighting. My wife and I live off-grid, completely solar for our electrical needs, and our solar power provides our lighting, our water pumps, fans, our computer and our computer network, and any of the other things that we need in our daily life. It does meet 100% of our needs. We do wish we could run air conditioning off of it, but while it would work, it wouldn't work for very long. When we went off-grid 4 years ago, there was really only one company at the time that had any LED lighting that was extremely efficient. This company was LC LED, and they had some bulbs, two of which we were using. One's a 3-watt draw, which puts out the equivalent of 40-watt incandescent bulb. And then they have a 7-watt draw that puts out the equivalent of a 75-watt incandescent bulb. These bulbs are rather expensive. They ran us over $30 a piece. And while there were some other companies making 12-volt LED bulbs, their draw was far too high. They were pulling over an amp a piece. Now here we are 4 years later, and there are quite a few other offerings available now. And so I decided to take a look at those, do a review on power draw and on the amount of light that they throw out, and that's what I'm going to be sharing with you today. We have a number of bulbs that we're going to look at, and rather than bore you with the details of testing every single bulb, I'm going to share with you how we tested the bulbs, and then at the end of this video I'm going to put up the results. And I'll leave that up for about 30 seconds on the end of the video. You can pause the video at that point and look at any of the results in more detail and make any copies of it that you might want to. Now, as for the bulbs themselves in our testing rig, well, let me show you what that looks like. Now, the bulbs, starting from left to right, the first one is a 12-volt compact fluorescent bulb. Nowhere near as efficient as the LEDs, but I just want to show it for comparison's sake. The bulb next to that is actually a 12-volt, 50-watt incandescent bulb. You can find these pretty inexpensively at auto parts stores. They're designed to either use in RVs or to use in trouble lights that clamp onto the battery. These are the worst as far as efficiency goes. The next two bulbs that we have are the two bulbs that we originally started with from LC LED. The one on the left being the 3-watt and the one on the right being the 7-watt. These are the two that we've been using for 4 years now. Now, some of the new bulbs that we've been using, these two are Lee Royal bulbs, sold by the same manufacturer and provided by the same vendor. The one on the left is a 7-watt, the one on the right is a 9-watt. And you notice the 9-watt is substantially larger. But when we tested these bulbs, discovered that their current draw was virtually identical, and as far as light output, if anything, the 9-watt, the larger one, was slightly lower. Not much, but it was actually a little dimmer than the one on the left, the lower wattage. So I opened them both up, and lo and behold, they both use the same LED chipset with the same number of LEDs in them. In other words, it appears that these are identical bulbs, just one of them put in larger packaging, sold as a higher wattage bulb and for $3 more than the other. Now we have a couple other bulbs. And the one all the way on the right was the largest, which we expected to have the most light output. And in fact, it really wasn't all that impressive and pulled quite a bit of power. The other thing that I thought you might be interested in seeing is what is actually inside these bulbs. What you've got is you've got a chip, a circuit board, that's got multiple LED bulbs on it. And then you have a large heat sink. Now these are LED, they are solid state, but they still put out a substantial amount of heat. In fact, I have burned myself a couple times on these bulbs. The other thing that's important to know, because these do put heat out, is that when you're putting them into light fixtures, you don't want to put them into enclosed light fixtures where there's no airflow. It's also best if you can put them in a fixture that faces upwards to allow the heat to escape. Although we've had a lot of success and no problems with putting them in fixtures that are downward facing but still open at the bottom. All of these bulbs, if you notice, have a standard mounting. This is called an Edison or an E26 or E27 base. There's very little difference between E26 and E27. You can consider them to be the same thing. But the reason we wanted bulbs that had these kind of fixtures is in our house, we wanted to be able to use all of the standard existing fixtures, table lights, floor lights, to simply be able to install these bulbs and use them in standard fixtures and use our existing light switches. Now for the testing rig, I have a regulated 13-volt power supply, basically putting out the same as our solar electric system puts out. And then I've got 2 meters. The one on the left is measuring the voltage coming out of the power supply, and the one on the right is measuring the current draw. Multiply the two together and you end up with what the wattage is that the bulbs are drawing. The other component that's needed for this testing is a light meter. And for that we're using an app on a smartphone. This one is free and it comes from, if I'm pronouncing this right, Keusoft, Keuwisoft light meter. And this is what we're going to be using. Now, lighting can be measured in a number of different ways. It can be measured in lumens, in candle power, in lux, and lux is what we're going to be using. It's a rather standard comparison. Now, one thing that you need to realize is that when we're doing this testing, the light meter has not been calibrated. But because we're comparing it at the same time to the same bulbs, we are comparing apples to apples, and we really only care about the comparative lux between the bulbs. So please don't take these lux readings as being precise. Compare them at your end readings. You'll probably get a different measurement, but it does show how these bulbs compare to each other. The other thing that we're doing is we are bouncing the lights off of a neutral color wall, because we don't want to know necessarily how much light is directly output from the bulb. We're much more interested in knowing what its lighting is going to be in a room. So if we were to take and measure directly in front of the bulb, that would give us a misleading reading because it would not reflect how the actual room is going to be lit up. So that's what we're going to be comparing, is a reflected measurement. I'm going to be doing the measurements right at the source of the light, but bouncing off of the wall and coming back to us. Now again, we're just going to do a couple samples for comparison's sake, and so you can see how the measurements were done, and then at the end I'm going to put up the results. Okay, this first bulb that I'm showing you is the 12-volt compact fluorescent bulb. I've let this one come up to temperature for about 5 minutes. All compact fluorescent bulbs do need to come up to temperature before they put out full brightness. And the light meter, which I realize is very difficult to be seen from here, but it indicated that the reflected brightness is 10 lux. And the power that we are pulling is 1.1 amps, substantially higher than you're going to see on the LED bulbs. Now, let me switch over to the 12-volt incandescent bulb. This is the one that is not modern in any way, shape, or form. This is the one that goes on to the trouble light or RVs. This one is pulling 4 amps, a rather ridiculous amount of power. And the lux that we are getting off of this one, let me get the measurement, we are getting 6 lux off of this bulb. So it is dimmer than the compact fluorescent and pulling 4 times the power of the compact fluorescent. Okay, let me switch over to the first of our LED bulbs. And this one is the Monster bulb. That's the brand of it. This one is pulling 3/4 of an amp, 750 milliamps. As you can see, the light is quite white on this. And the lux rating on this one, let me clear this out. And the lux rating on this one is 19 lux coming back reflected. All right, let's try a couple of the other bulbs. The next thing I'm going to do is I'm going to load the lamp up with 3 different 50-watt equivalent LED bulbs. All right, the bulb that you're looking at now is one of the bulbs that we originally started with when we first went off-grid. This is a 50-watt equivalent, and its reflected lux is 17, and it is pulling 0.26 amps. So this is an extremely efficient bulb, which is why we originally went with it. I'll give you a look at this one. And then the next bulb I'm about to turn on is the Sun-Thin. Now this bulb we've been very pleased with in the testing. It is putting out 39 reflected lux, and it is only pulling out 0.37 amps. So it's only slightly more current draw than the bulb we originally started with, but rather than spending $30 a bulb, this particular bulb goes for $10. Most of these were sourced off of Amazon, as you'll see when you look at the result sheet later on. And then the last bulb, as you can probably see, is quite a bit dimmer. This one is manufactured by Zhuy, Z-H-U-Y, and it's putting out 26 reflected lux, and it is pulling 0.35 amps. So it's pulling almost as much as the Sun-Thin, but not putting out near the brightness. I realize that this camera is going to automatically adjust for the brightness, but hopefully when I turn and switch back and forth between the lamps, you can see the difference between the two. Now the last 2 bulbs that I want to show you are the 2 Liroyal, L-I-R-O-Y-A-L bulbs that I had mentioned. I purchased in a 9-watt version, which is a substantially larger version, and a 7-watt. But when I actually tested them, the 9-watt put out 41 lux, the 7-watt put out 43 lux, the 9-watt drew 0.48 amps, the 7-watt draw 0.49 amps. So the 7-watt actually pulled a little more power, put out a little bit more light than the 9-watt. Both of them are lit right now, but let me show you the comparison. This is the 9-watt, and this is the 7-watt. And as long as my automatic light balancing is not throwing this off too much, you should see that they look virtually identical. And now what I'm going to do is take the covers off of them so you can see why they look identical. Okay, here are the 2 bulbs side by side. You'll see that both of them have the same number of LEDs, 7 LEDs. And if you can see the part number, this one is HK233. And lo and behold, this one is HK233. So it appears the only difference is in the size of the heatsink. The bulbs themselves appear to be identical. In all of the bulbs that I've evaluated so far, the smaller version of this, which is the 7-watt rated, is our current favorite. It throws the most light of all of the bulbs that we've looked at, and its price point is the best. So overall, we hope that you've gained some useful knowledge out of this comparison. If you wonder why we run our solar-powered home on 12 volts rather than 120 volts, like most solar installations, it's because of the efficiency. Most of today's inverters that convert the battery power to 120 volts AC are anywhere from 80 to 90% efficient, which means you're throwing away 10 to 20% of your power. And many of today's devices that you use in the home actually run on low power DC, and they use transformers, those little black boxes that plug into the outlet. They use those to reduce that 120 volts back down to a low voltage in the first place. So everything we've got in our house, our ceiling fans, our lights, our water pumps, our television, DVD player, computers, networking, everything runs on 12 volts because it's a lot more efficient and we're making better use of our power. And that's also why we wanted to find bulbs that were the most efficient. So right about now, I'm going to be putting up the chart, and I'll leave it up for 30 seconds. You can pause this video and get the information off of it. If you're interested in more information, we do have a blog and a website. It is www.offgridgeeks.com. That's OFFGRIDGEEKS.com. My wife and I both have a high-tech lifestyle. Our jobs are technology related, but we're doing it all from the woods, from our solar-powered house. And we have articles and we have a blog on our 12-volt lifestyle at that web address. Again, www.offgridgeeks.com. And again, I'd like to thank Jim and Survival Weekly for running this contest and giving us a chance to share this video. Have a good day.